Hey, what's up, Chem peeps? Let's talk about strength of acids and bases. That's our goal for today. Two big things we're going to think about. We're going to explain which species, which things are in large concentrations for a strong or weak acid or base, and then we're going to explain how to calculate the hydronium ion or hydroxide ion concentrations for a strong acid or base. First up, strong acids and bases. These things will completely ionize in solution. 100% ionized. For example, if you were to take hydrochloric acid, which is a strong acid, and put it into water, it's going to completely ionize into hydronium ion and chloride ion. There's going to be no original HCl molecules. You can see that depicted using this equation here. HCl, put it into water, completely separates into the hydrogen or hydronium ion and chloride ion. Since strong acids and bases completely ionize, the concentration of hydronium or hydroxide is equal to the original concentration of the acid or base, respectively. That's because the ratio between the acid, Ha, and the hydronium ion is 1:1. So however many acid molecules you start with, or how many moles of acid you start with, is equal to the moles of hydronium ion. One important exception. There will be some strong bases that are group 2 metal hydroxides. Because the group 2 metals form a +2 charge and they're partnered with hydroxides that are -1 charge, every one group 2 metal ion, you're going to need 2 hydroxides. Lastly, don't confuse concentration, molarities, with strength. You can have very small concentrations of very strong acids. Next, let's talk about weak acids and bases. If strong acids and bases ionize completely, weak acid bases do not. Usually much less than 10% ionized. So the type of calculation that you'll need to do to determine the amount of hydronium in solution is a little more complex, and we'll learn about it more in the AP chemistry class when I see you all again next year. Here's a little simulation to give you a bit of a visualization of the differences that you just thought about. This equation at the bottom describes an acid placed in water, forming its conjugate base, A- or hydronium. In a strong acid, you'll notice that it's completely turned into products. Whatever amount of HA I had originally completely turns into products. Conversely, in a weak acid, you'll notice that there is much of the original HA or weak acid molecules remaining because it did not completely ionize. Sure, you're going to get some product, but most of it is going to stay as weak acid molecules. Same thing with the base. If you have a strong base, you'll notice represented here, MOH, you don't see any of those gray formula units in solution. That's because they've completely ionized into their individual ions. Strong things completely ionize. Weak things, however, you'll notice the weak bases, there's a lot of that still present in a weak base solution. Some of it will have ionized, but not much of it. That's it for strong and weak acids and bases. We'll do some practice in our next class. Have a fantastic day.